Okay, so today would okay, last week we talked about Azure Firewall, but we'll just quickly do a recap. Then when it comes to working on the activities, would recreate it to have an overview of how that works. Then we'll talk about DNS, VNet peering, routing, endpoints, load balancer, application gateway. We talk about network watcher, traffic manager, and front door. So in the last session, basically we started with what a VNet is. Talked about VNets, and we talked about subnets, where a subnet is just a section of your network defined. Hello, can you mute? Your mic is on. Okay, so where a subnet is just a section of your network, and some of those things we discussed about within a VNet are network security group that allows you to define network or private traffic restriction based on a subnet or maybe a NIC, which is the network interface adapter of a virtual machine. You can control what traffic is allowed in or probably out. And another network security feature you could also implement is a firewall, where for a firewall, it actually restricts network flow to the network itself. So there's a difference between your subnet and your network. So we have to understand that your NIC operates at the your network security group operates at the NIC level and at the subnet level, while your firewall operates at the network level itself, so that you can control what traffic is allowed on any part of your network. Now, there's no way you talk about networks without talking about DNS. And how do they relate? We know that when you talk about network, you're strictly talking about IP addresses. Yeah, you can access resources by means of their IP addresses. But in human nature, it's not easy for us to remember a whole lot of IP addresses. So we need a way to be able to assign friendly names to those IP addresses, and that's when DNS comes in. We have actually talked about DNS in the past, but if we still remember, just a recap, a DNS is just a register of your IP address to your name. And when you say you have a DNS server, it means that that registrar or probably that database of IP address to name mapping is on that particular DNS server. And you could have a DNS host, or probably, let me say, a DNS provider. Okay, before I talk about DNS provider, and we said your DNS can be public or it can be private. So private means that you have a namespace which is only accessible within your network. So name to IP address mapping for that namespace is your private DNS. So for instance, if I have my local network, and within my local network, I have a domain such as raji.com, where that raji.com is not accessible on the public internet. But for resources that I have within my local network, I want to be able to access them as server1.raji.com or probably server2.raji.com instead of remembering those IP addresses. Then what I have there is a private DNS. But if I have a routable domain name, that is, I've got to register that domain name and tie it to public resources, it becomes a public domain. And the way you get that is that you go to DNS registrars or perhaps DNS providers, buy a domain name, you pay for it, and when you pay for it, they maintain the DNS records for that domain name on your behalf as part of the service they offer you when you buy the domain name. they maintain the DNS records. So there you can begin to map IP addresses to names. So which means you are mapping IP addresses to names for resources that are accessible on the public internet. For instance, if I go and register rajiadewale.com, which is already registered, I can begin to use rajiadewale.com as a namespace for any of my resources that I have there in the public internet. Maybe www.rajiadewale.com, mail.rajiadewale.com, server1.rajiadewale.com, as the case was recalled, maybe. So this service that the registrar is offering you is also a service that is available on Azure. So which means that within Azure, you can host your public DNS. You could also host a private DNS. So private DNS, if you want a non-routable DNS name for resources that you set up within your VNet. So if I have a server, even though the server is not accessible publicly, I don't want to always access that server using an IP address within my network. Now we need to understand that all this is actually, especially when it comes to private, the boundary is actually your own local network, because it is not something you could access publicly. Why the boundary for a public DNS and domain name is actually the public, which is the internet. So you could access it. That's why you can be here and access any resources on Google. You can be here and access any resources on, let's say, on Facebook. But say you have maybe, let's say, is the check here. So maybe you have a network, you are a network administrator, and you have a network in your office that when you get to the office, you connect to maybe certain applications, which is internal. Even though you are using a domain name tied to it, that is not accessible on the public network, because the boundary is your local network, which means that whoever needs to be able to access that resource using the name must connect to your own local network. So that's the way that, so that's the major difference. So within Azure, you could host private DNS for resources within your VNet, because your local network within Azure is your VNet. While you could as well host public DNS for resources either on Azure or probably anywhere else, because it's public. So what do you need to set up a DNS within Azure? You just need your own domain name, your custom domain name. Mind you that by default, there are a number of default domain names that are used, because even within Azure, despite the fact that it's not important that you define resources or probably that make use of DNS within your network infrastructure, so which means you are comfortable with accessing resources using IP addresses. But in the background, Microsoft has made available default name for resources, just so that that integration is there. And if you so now decide to say eventually you want to use DNS, then it doesn't become a challenge. So you have these Azure AD mini.co.allmicrosoft.com. For some of them, they may also be familiar with, let's say, the M365 platform also, where DNS is an integral part of it. Even if you don't come with your own custom domain name, there's already a default domain name there. So just that default domain name has a number of parameters that gives it a way to say, oh, this is the platform where this resource is coming from. Like you'd always see this on Microsoft.com on it. And sometimes it might not be friendly as such. So you can come with your own custom domain, or even buy a domain and have the the DNS registry hosted on Azure. So when you create your subscription, this default domain name is always there, and you can always change or probably customize it if you already have your own custom domain. So now there are two types of now, if you remember that the namespace, I can remember we use the instance of, let's say, family name. The namespace, let's say raji.com, would have a database where the database or registry contains the mapping of IP to name. This namespace and the mapping of IP to name is actually called a zone. So if I have a raji.com DNS zone, it means that I have a registry of name to IP address mapping for the raji.com namespace. So, and that word zone, if you remember when we're setting up DNS on what's it called, using legacy infrastructure like Windows Server, what you also create is what you call a zone. Now, you can create two types of zones in Azure. You can create a private zone, and you can create just a DNS zone, which by default is a public zone. So what's the difference? It's just the same thing as what I had explained before. A private zone is for a domain name that you are bringing in that is not routable, but you want to be able to use it within your VNet in the cloud. While your public zone would be that which you have bought a DNS for, and you are maintaining a public DNS server or probably public DNS zone. Now, if I already own a domain name, like I currently own rajiadewale.com, which is being hosted and managed by Namecheap, or let's say GoDaddy, and I now decide that although I've paid for that domain name and it is mine, I'll continue to pay for it annually. But the secondary service which comes to buying a name, which is hosting or maintaining a public registry for your zone, is a secondary thing that the provider does. You can choose to host it with the provider, you can choose to host it elsewhere. If you currently have an existing domain which you have bought and it's currently being hosted by, let's say, a GoDaddy, and you want to transfer it to, let's say, Azure, then you do what you call DNS delegation. What does that mean? It means that I am now delegating my DNS servers or name servers on Azure as the authoritative DNS server or probably zone host for my domain name. So which means I am moving that zone off GoDaddy and placing it on Azure. That is what that primarily means. It is not important. It is not a must. But if you feel like Azure DNS would offer you more flexible features in managing your zone than GoDaddy would offer you, then you can do that. Moreover, another advantage is the fact that if majority of my infrastructure are on Azure and I use public domain names that requires my zone's IP address mapping, then why should I begin to create records separately? So if I do one or two things on Azure that requires me to create a record or probably modify a record, I'll have to go back to GoDaddy, log in, create the record, wait for propagation, then come back to Azure. Why not do all of them within the same what's it called, space? That is what you call DNS delegation. Then I already talked about private DNS zone. It's for your own custom domain name, but that is not routable. You can create both of them within Azure. I would see how to do that briefly. So I would come to okay. So if I want to create if I type it DNS, I can see DNS zones and I can see private DNS zones. DNS zones will be for my public DNS. If I have a custom domain name and I want to delegate it or probably transfer it to Azure, I can do that here. Or be private. If for a private DNS zones, you don't need to buy a domain name. So let's take, for instance, if I come here to say create, so I have a resource group here. Let's say 7. Then let me call this let me say ajao.com. So I want to create a let me I shouldn't use that. Let me do something like test week 7. So if I have a private domain name, or I want to be able to access resources locally within my Azure network using the testweek7.com. So that if I have a server, the DNS, local DNS record for that server will be server1.testweek7.com. Then I'll create this. Mind you, this is private, so which means I can't use this on the public network. So I'll create this and I'll say create. So why this is coming up, let's look at creating a public domain name. Can I log into Namecheap here? I want to show us something. I'll try to. Okay, next for. Let me see if I'm able to access my Namecheap account and show us something. So I'll come here to say why this guy is creating. Okay, so here I have my private DNS already up. So once you have a zone, all you need to do to use your DNS is just begin to create records. And I believe we already know what records are and what are the types of records you have. Your record is just a mapping of your IP address to a name, or probably service to a name. So this is a private. So if I'd created so for instance, let me come here. Would need a number of virtual machines in this session. So I'll just create one here. So I'll create virtual machine. Okay, 7. I'll call this, let's say web 01. Yeah, East US is my zone. Yeah, this is fine. Go next. Change this to just standard. Go next. Network. I already have this virtual network, and okay, I have this subnet. I don't want this guy to have a public IP address, so I'll go and just say create. So if I have that guy, and eventually when it is created and I know the IP address, then I can come here to say web01, which is the name, how I want to address that particular server. Then I create an A record. So depending on what IP address that guy gets, I'll put the IP address here, and here I have the A record. So which means locally within my VNet, which is my local network on Azure, I can address, even if I want to connect to that server, instead of knowing the IP address, I can connect to it using that particular name. That is what your local DNS is all about. So now let's look at, okay, I'll download this guy. Oh, did I finish downloading it? Okay, yeah. So looking at DNS for public zones, I'll come here to say DNS zones just the same way. To see DNS. Okay, I should go. Okay. So yeah, I'll come here to say create. I'll come here to say week 7. So here I have a public DNS name, something like this. I'll go here and say create. So when this guy is done, okay, it's done. If I say go to resources, so here you can see this is a public routable domain. If I come here and do something, let's say is if I ping the IP address, it's going to return, so which means this guy is resolving on the public network, that's on the internet, it is resolving. So which means the DNS server is responsible for this resolution, and that DNS server is actually somewhere else. So if I come here to say nice, okay, let's say let's look up. I put this here. These are currently the DNS servers, and these DNS servers are managed by this guy. And these are the 2 DNS servers managing my zone. They are the 2 DNS servers managing my zone. But now I have created a zone on Azure, and Azure had provided me with 4 DNS servers that can help me manage my zone on Azure. All I need to do now is just transfer or delegate the management of this my DNS zone, which is rajadwali.com, and I delegate it to Azure. And how do I do that? Your host provider would always know that sometimes you may not be willing to continue to use them as your DNS host. So if I come here, this is my DNS settings with my name provider, which is this guy named Chip. And these are current records that I have on that particular DNS. And if I come down here, currently by default, these standard name servers that is written here are these 2 guys. That I have here, the .6 and what's the second one? .6 and .5. Those are the 2 standard DNS server offered me by Namecheap. But if I want to change it to say, okay, I don't want you to manage it for me again, no. I want to move it, I want to delegate it to Azure, then I can come here to say custom name servers. Then I'll now put these name servers that Azure had provided me. These name servers, I'll put them there, one after the other. Once I do that, now if I need to create records, I don't need to go to Namecheap again. I can come here and begin to create my records, because Azure will now be responsible for managing those records. So this is for public DNS, and the one we created earlier is for private DNS or private zone. So that's that for DNS. So coming back to the slide. So now, let's talk about VNet peering. Now, I need this space. VNet, like I said, is the boundary for networks within Azure, just like your LAN or maybe your switch, as the case may be. Sometimes you would always want to attribute a switch to a LAN because by standard, you'd use your switch to create a LAN. So my LAN is a boundary for my local network. Now, if I have more than one network, separate networks entirely, there are various ways by which I can link them up. One of those ways is if you have a router in between them, such that traffic here, when there's any traffic that is destined for any resource outside this network, it will send to the router and the router sends it to the other network. Then within this part, you have routing table for some of us that are familiar with networking. Implementing this physically would mean you'd have maybe a layer 3 switch or maybe a router to link two different networks together. However, even though it is still very much possible that if I have two VNets, VNet 1 and VNet 2 within Azure, there are several ways by which I could link them up together. Number one is that I could use a virtual appliance. A virtual appliance would be any appliance that can serve as a gateway. Maybe it's a firewall or even a router. You can deploy a router, a virtual router within Azure and link them up so that you can do your dynamic routing between both VNets. But Microsoft also has offered a more faster way by which you could link up two VNets together using a means called VNet peering. With VNet peering, all you just do is connect the two VNets and they become routable. So which means that VNet 1 is reachable from VNet 2, VNet 2 is reachable from VNet 1, and the traffic is managed by the Microsoft backbone. So which means you're within the Microsoft data center, the traffic is local. So which means you enjoy that very high speed or probably extremely low latency. That's the way VNet works. So if I come here back to my here I can see that I have one VNet, I have another VNet, even though one is in region 1, the other one is another region, if you remember. And mind you, this region could mean that one is in US, while another one is in, let's say, China. So I have a VNet in the Azure region in the US and that VNet in the Azure region in China, and I need them to link up together. Then I'll do VNet peering. So, and like I said, that VNet peering, the old traffic is actually being managed by the Azure backbone. So, which means the traffic is local, it is not routed through the internet. And you can do this across region, or probably you can do this with VNet within the same region. And you enjoy great performance and seamless data transfer because latency is extremely, extremely low. So, how do you create a VNet peer? First, it means that you must have your networks available. For instance, currently I have how many networks here? I have just one VNet here. So I would quickly create another one. Still in this place. So I'll call this guy let's say DR. I'll call this, let's say maybe DR Cloud VNets. So maybe I have two, yeah, I'll leave it this way. Should use default subnet. So maybe I have two different cloud-based data center and I need to link them up. I'm using one as my HQ, I'm using the other one as my DR, and I want them to reach each other using VNet. If it were to be physical, so let's assume that you have a network in main 1, you have another network in, let's say, rack center. There are two different networks. Maybe you are using your main 1 as your HQ and you are using rack center as your DR, and you need to link them up. Consider the fact that they are extremely different networks managed by different providers. Then you have to look for an intermediary, what's it called, link. Like releasing a fiber connectivity that will link up your HQ to your DR. So, but this, you are doing it just like anybody without thinking, just do a click. So if I come to this VNet, I'll come here to peering. So your peering can be done from one end. If I do it from this end, from my, so mind you, I have two networks now. Let me come back here to network. So I have two networks here. One is HQ Cloud VNet, the other one DR Cloud VNet. And if I want to peer them, if I come to peering, where is it? Peering. I can either do it from the HQ side or probably I do it from the DR side. So I'll come here to say add. I'll call this is HQ. So I'll say HQ underscore DR peer. Allow remote virtual network traffic forwarding. So which means if a traffic is coming from HQ and it gets to DR, even though the destination is not DR, is DR allowed to forward that traffic across its own routing path? If I want that, I would say. But if I want any traffic coming from HQ to DR to not be transferred out of DR, then I can block that. Then also, do I have a gateway between both machines? The idea is that even though if the traffic is coming and it's hitting DR, I still want to be able to manage some of those traffic manually, doing some traffic restriction and some of those things we do on networking. So this guy, then my remote virtual network. So on my HQ, the name of the link will be HQDR, although it could be any name. But for ease of identity, why on my, because I said you create this just from one side. So it doesn't really matter where you create it, but just making sure that this first configuration here is speaking to HQ Cloud. That is my active VNet here. Why the second configuration, even though they are the same set of configuration, is speaking to my DR. So yeah, I would say I'm giving this guy the other way around. I'll call this DRHQ. And I know my resource ID. I don't know it. I have to go and copy, so get it for me. Yeah, so it is I'm going to DR. So for this also, I would select all these options, then I'll go ahead to say add. So this guy is done. It's currently saying updating. If I come here and refresh this also, you see it has appeared here and saying updating. And once it is done, so what will these updates do? This is the old configuration being done on the Microsoft own infrastructure, creating routes, creating links to link up the two networks together. So which now means that if I have a VM or have any resource on this network, it will be able to access any VM or probably any resource on this network. That is what VM peering does. Let's see. Okay, so we can see the status now as connected. And this guy is using this IP address space, but I believe both of them are similar IP address space because that is always the default. And both of them are using the same IP address space. So I would come back to this guy. So you also have this concept of gateway transit connectivity, which I'd already explained. Your gateway transit allows peer virtual network to share the same gateway and get access to resources. And in this particular case, we are saying, let's assume I have this, this is a VNet, this is another VNet, and this is a hub VNet. Both of them have been peered. Both VNet A and VNet B have been peered to the hub VNet. So which means resources in VNet A can access the hub, resources in VNet B can also access the hub. Now, the hub VNet now has a gateway. which is a VPN gateway, maybe to on-premise. And if we understand by default, if there's any resource in this hub, let's say this VM here, the users in this VNet can access this VM. But by virtue of the fact that this hub has access to the on-premise by means of a VPN gateway and I have a server on this on-prem, will this guy here be able to access the on-premise without having a direct link with on-premise? That is what transit gateway is. And for you to have transit gateway, if you remember, I said you'd have to, when we're setting up that stuff, you have that option to say you allow forwarding. You have to allow forwarding. And when you allow forwarding, by default, if this hub VNet has access to on-premise, then this guy here on .16 would also have access to on-premise, because the traffic will be sent to hub. And since hub already have its established connector with on-premise, it will forward it to the on-premise, having known that that traffic is meant for the on-premise network. So which means you don't have to create a separate VPN gateway on each of these spoke networks. That is what Get Transit and Connectivity is talking about. So that is that. Any question? So if there are no questions, let's move to network routing and endpoints. Now, routing, there's no way you have networks without talking about routing. And so far, you'd see that we've not had anything to do with routing to a large extent. And that is because a lot of the routing required to set up a network, especially within a legacy environment, a large number of them have been done for you within the cloud, which is Azure, such that all you just need to do is to set up your network, do your configs of services as required, and you are good to go. And even in rare cases, would you have to use a third party, although even though they are available, when you go to the the Azure marketplace, you see a lot of third-party virtual routers that you can use to manage traffic within your VNet. So a large number of time, you might not really need them, except in specific cases where your use case or product requirements requires that you have a router. Then you can now begin to use the router to manage a routing. So that's because they are what referred to as a system-defined route. Microsoft has already established use cases of where you would want service A to be able to access service B, even though they are on separate subnet or probably they are on separate network, then they do the routing for you automatically. That means they are the message that you would need it, and it's been done. So your system routes direct traffic between virtual machines, on-premise networks, and the internet. So because, for instance, on the legacy network, if I have a local network and I want to be able to access the internet, then I get a router, except if it's a plug and play router. If I'm getting an intelligent router, I would have to configure it and create routes. I have to do ifconfig, route, blah, blah, blah. All those stuff the network there will do. I would have to do it. If I have two separate networks, maybe I have the Abuja office, I have the Lagos office, I also have to configure routes at both ends to say traffic coming from Abuja. If it's not going to the, if it's for Abuja, it shouldn't send it to the internet, just send it directly to the Abuja office through the one link or private fiber link that we have between both. So some of those cases have been identified. For instance, traffic between VMs on the same network. So by default, if I have two VMs on the same network, they will be able to reach each other because there's already a system route. If I have VMs on separate subnet, but on the same virtual network, separate subnet on the same virtual network. But if you remember, looking at the traditional way, if I have two subnets by default, resources on two separate subnets would not be reachable, except I define a route for them. So, but here it's been done for you. So you just set up your VM, your subnet, and you're good to go. Then also, data flows from your VM to the internet, which is outbound traffic flowing out of your network. The path for it to get to the internet has also been defined for you. So which means you don't have issues. You don't have to do anything. Communication between VMs using a VNet to VNet VPN. So if I have a VNet here, I have another VNet here. And I do now, one of the ways by which you can link up VNet to VNet is number one, you can use peering, which we just discussed. Or you can decide, because you want to manage it yourself, you can put a gateway appliance here and do VPN, or put a gateway appliance there and do dynamic routing. These are different ways by which you can link them up. So, but if you are doing VPN, as long as what you are setting up is an Azure VPN, the link and routing will be done for you. Or site to site, or express route. So we're still going to talk about site to site or express route, but let me just briefly, in case we eventually miss it. So if I have an office in London, I have the office in Nigeria, and I need to link. So this office, they have their own internet. Their provider is, let's say, Orange. I guess there's a service provider in the UK named Orange. And here in Nigeria, our service provider for internet is Main One. Now, if I have these two locations and I need to link them all together, I have several options. One of the most common and the cheapest option is to do what we refer to as site-to-site VPN, which links up the whole of the network here with the whole of the network here. So what does that mean? The network engineer in London look for either maybe on their router supports it, or maybe on their firewall, which most firewall or all firewall, we say all firewall will allow you to do site-to-site VPN, or maybe they go and get a specific VPN appliance. You get it here. Same thing, the guys here, they will get either a router that supports site-to-site, or they get a firewall or a VPN appliance. You get it here. They will connect their VPN appliance to the internet. They will connect it here to the internet here and set up a VPN tunnel using IPsec and specifying that what you want is site-to-site. So which means it creates a virtual tunnel on the internet, because the internet is a global network. So once you are connected to the internet, you are connected to the rest of the world. And since London and Nigeria are part of the rest of the world, once London connects to the internet and Nigeria connects to the internet, virtually both of them can connect. But due to the fact that the public network is not secured, that connection between both of them, you want it secured. You now do a tunnel, which is what the VPN is. So that is one technology by which you could link up both offices. Another technology you could possibly use is go and look for a service provider, a network service provider who has edge presence. A network service provider who has full presence or edge presence in both locations. So I have a network service provider, let's say in London, it has an edge presence in, let's say, Nigeria, or maybe the one in Nigeria has an edge presence. When I say they have an edge presence, which means by means of global routing, their network infrastructure, probably their network backbone, reaches London. For instance, the Galaxy backbone, which links across the sea, is actually linking up a large number of Europe service providers to Nigeria. And one of those service providers that makes use of private consumer that Galaxy backbone is one. So which means that if you have an office in any of the European countries where the Galaxy backbone has an endpoint, then one can link you up using a direct link to that particular location. So in that particular case, you can look for a leased fiber link that will link your London office to your what's it called, to your Nigerian office. So one option is site to site, which I talked about, which is something you can set up within Azure. Then you have express route. Express route uses the second methodology where I'd explain. That means that you have a service provider in London that has an edge presence in Nigeria, or the other way around. And I'm giving an example of Main One and the Galaxy Backbone, what's it called, network. So Main One currently, by virtue of the fact that Main One is on the Galaxy Backbone infrastructure, we links Main One to a lot of the European, what's it called, country. And a lot of those European countries are where you also have Microsoft data center. You can link up your physical data center in, say, Lagos to your virtual data center in Azure, irrespective of the region, although it can be region specific, but as long as it's within the covered region, you can link it up without routing your traffic through the internet. You are routing it directly through that Galaxy Backbone that connects Main One through cables, fiber gigabit cables that runs through the sea directly to wherever your VNet is in any of the European countries. And it is called the express route. You can use any of them to link up your physical office to your virtual network in Azure. And when you set up either a site-to-site or an express route, the routing required is automatically defined for you. Let me put a context to Eshali's express route. Sometime last year, was it last year? Was it before COVID? I guess it was before COVID. There was Microsoft had a network outage across a lot of their data center. And when you say network outage, it means that they had service issues. People couldn't reach their service. You can't reach your M365 network. You can't reach your virtual machines. And the reason is that they have issues within the network. And when they did a root cause, that is trying to identify troubleshooting, what was responsible for it? It was linked to Nigeria. And at an instance, when the news, a large number of times when you have outages for some of those service providers, because a large number of organizations, individuals have got services that are managed on this infrastructure, when the outage happens, it's always global. So you see the news on the internet, they would also try to begin to push out a lot of information to see how they can manage the people and say, don't panic, we are managing it, and they begin to give bit by bit, minutes by minutes update and stuff like that. So eventually when they did the root cause, they identified, they say, okay, we identified the root cause. It has to do with a, what's it called, network change on one of the edge in Nigeria. And some people were edge in Nigeria. And okay, Main One, is it that Main One has been hacked and stuff like that? So the news got out. But that wasn't the issue. You had, and now Main One is one of the edge provider for express route service. What does that mean? It means that Main One's global network backbone has been linked directly to Microsoft data center. So which means you could use Main One's own infrastructure to reach data center. So they are reselling that service. So which means the Microsoft data center has direct link to Main One data center and vice versa. So a network engineer in Main One updated a network configuration, a network route configuration on their router in Main One. And that, what's it called, network route, had maybe some abnormality or probably inconsistency. And once you update it and you are linked, it propagates because you are changing routes, especially when you are using BGP. This one gets the route on this router here in Main One in Lagos. Main One is Lagos, is connected to another organization in South Africa. That one gets the route, forward it to another router in India. That's the router in India, forward it. And each of those routers begins to get that information, more or less like a broadcast, and they begin to share it. Then it causes that disruption. So that just gives us an idea of how that global linking can be done. So when you do this also, routes are automatically created for you. Now, there may be scenarios where you are not comfortable, or your use case or your architecture or design would not work with system-defined routes, then Microsoft allows you to create your own route yourself. For instance, we said by default, routing between two subnets on a network is done for you. So which means when you set up two subnets within the same network, automatically they can reach each other. But now, maybe on one of the subnets, I have, like for instance, my front end subnet, I have forward-facing infrastructure. On my back end subnet, I have restricted infrastructure that I don't want every traffic coming from front end to get to back end. I want to restrict, I want to be able to limit what traffic comes from front end goes to the back end. So I would introduce an appliance. This appliance can be a router, it can be a firewall. Once I introduce this, then I have to change the route. Currently, the route is saying is that the default system route is saying if any traffic is coming from front end subnet, automatically send it to back end subnet. But I'm saying no, that will not work for my use case here because I want to be able to manage that traffic. Then I'll go and create my own routing table, and I'll say any traffic coming from front end that is destined to back end, send it to this router. Here, I would have configured what I want the router to do with it before the router can now forward it to backend. So in this case, I'll need to create a user-defined route. So you could use it to control your network traffic and specify exactly where your traffic should flow to. And your network, your next up, which is this appliance, can be a virtual network gateway, it can be another virtual network, it can be internet, or it can even be a virtual appliance. So let's see how we create a route here. So I'll come here, I'll say route. So here I have route tables. Currently I don't have a route table. I'll say create. What's this guy here? Let me call this RTO1. And I'll say create. And mind you, for some of us that are familiar with networking and routing also, for each of these dynamic routing protocol that I have on router, also they make use of route table. And what's a route table? The route table is just a list of source, destination, and address. Say if you are going here, follow here. If you are going here, follow here. If you are going here, follow here. That is what the route table is. So this guy has been created, and I'll come here. So once I have the route table, what I need to do is to create route. So if I come here to say add route, I'll give this guy, let's say subnet sub to router. Let's assume I have a router. I'll just give instances here. So if you remember, if I say route print, if you remember when we're talking about routing, we also talked about route table. And I showed us this. This is the route table on my system that defines how traffic are sent out of this system. And the first one here, destination, subnet mask, my gateway, and what interface to have, on which interface to have this gateway. So this is saying any network, send it here. But when I have specific network, I can begin to specify them here. For instance, if I type this IP address, I'm saying don't send it out to anywhere, send it back to this interface. That's why it's called a loop back. Send it back to myself, or it's called a local host. So the same way you specify route table here, where you specify where you are going to, and how do you identify where you are going to, and which gate should you follow is what you refer to as route table. And the same way is what you specify where you are going to. I'm going to a particular IP address, and I put the IP address, let's say 10.10.1.0/24. Where I am going to, which gate should I follow, or should I take out? So we had said your home address, or probably the appliance, can be virtual network gateway, virtual network, internet, or probably virtual appliance. Then that means I would have created, so let me show us, I would have created a virtual appliance like a router, and I know the IP address of that router. And if you come back here, right, I don't have any router or probably virtual appliance or private gateway, but I'll show us that if you go to the marketplace, if you have a need for a router, you have already configured appliances. Just come here and type router. So here you can see I have a Netgate router, I have a Cisco VH cloud router, Cisco cloud series router. So I can use any of these. I have Arista. I can specify that, oh, I want this. Once I configure this, which is actually a virtual appliance that would use my VM and instance, the VM instance, to set it up, then what I'll put here is just the IP address. So I'm saying that if on this subnet, okay, once I create this, so let's assume I'll still go and do an assumption. Let's assume I've created my virtual appliance and the IP address is this. Sorry, .5. The IP address is this, and I say add. So I have my route already defined. Then I would have to tie this route to a subnet. If I come here and I say associate, I'll come here on which is the so I'm not seeing my subnet here because what I can quickly do is so your routes are actually region specific. So your route has to be in the same region where you have your VNet. So I don't have a VNet in the ECS2. ECS2, I have them in ECS. So I'll go here and just quickly create this guy is in ECS2. So I'll quickly create a network and a subnet in ECS2 so that we can associate that guy to it. ECS2. I'll call this let's say DMC. Let's just secret. So this guy would have a default subnet created. So I can say, so what that would mean is that me saying that if I have any resource here, let's assume I have a VM on this network, and that VM needs to go to this network, this one here, this network here. It should route it through the appliance I've specified here. So I'll come here to say associate this guy. Come on, come on, come on. This guy needs to come in. DMZ, VNet. I thought I changed this guy to ECS2. ECS2, ECS2. Next. Proceed. Accept. So you have some resources that if you have provisioned in one region, you can move it to another region, but not all resources support that option. For some, if you already provisioned them in a particular region and you want to take them off that region, you have to go and recreate them. While some, it's possible for you to move. You can actually move a VNet, which is what I'm trying to do here. Move it from ECS to ECS2, so that it becomes available for me to associate. So this might take a while. We'll come back to this and do the association. So that's the idea about VNet. Now, let's talk about service endpoint. Services are all those resources you can consume within Azure: storage, SQL, VM, load balancer, web application gateway, firewall, all those stuffs. They are called services, maybe app services and the like. They are all called services. You can see them here: SQL, web storage, Vault, registry, Cosmos DB, Azure Active Directory is also a service. They are called services. Now, all these services have got a way by which you connect to them. And that way by which you connect to them are called endpoints. And for a large number of them, those endpoints are public. Public meaning that you could access those services through the public. For instance, I could log into Azure Active Directory from the public internet. All I just need to do is to authenticate. If I create a storage, if you remember, we created storage, and for one of those storage, I even mapped it locally on my system because I'm connecting to it publicly. If I have a web service or probably a VM, by default, my VM is also public, especially when I tie a public IP address to it. If I have a web app service, it is also public. It's come with a public IP address. So which means that access to all these services and resources are through public endpoints, and the routing is done through the public internet. Although there's no challenge to that, but however, you might begin to see issues of maybe security. So which means if I am on a network now and I'm trying to connect to my Azure Active Directory, there's someone on the same public network and the person is sniffing or probably doing anything. They can capture traffic, although there are a lot of more securities within those services that can always, what's it called? Prevent you against such petty kind of attacks or probably intrusion. But apart from that, also, your speed of connectivity is also dependent on the public internet, that is latency. Then also, for some of those services that are shared services means that I have a pool of it. Just a chunk of it is given to me as I pay. You have another customer that has just a chunk, but the access of the whole service is through the public. So which means even though there's a kind of segmentation that separates my own part of the service from other own customer service, it just means that whoever is accessing the whole pool as a whole, indirectly, virtually has access to mine, because if there's an attack against the whole pool of service, it could also affect or probably impact my own, as the case may be. That's the idea. But Microsoft has actually provided two different ways by which you can restrict access to those services to your own local network. That's number one. Then also allow you to access those services also locally. From your local network, you access it locally without routing the traffic through the internet. So you have two services that does that. The first one is a service endpoint. This limits network access to specific services, not all services. And I said not all services, are public by default. So restrict access to specific services. So which means if I have, for instance, I have a storage here. I've created a storage account. I want to restrict access to that storage account from maybe a virtual network that I have, or from a specific IP address, so that if I connect to that storage from another IP address or from another virtual network, I would not be able to access it. That is what a service endpoint does. Then you have private link. Now, just to add, even though I am doing access restriction to say, okay, only this virtual network should be able to access this virtual machine, this virtual storage or storage account, or only this IP address should be able to access this what was it called, storage access, storage account. Access to it is still through the public network. However, it is only restricted to specific IP addresses. So which means if you are doing it, if you are connecting from a different IP address or probably from a different virtual network, maybe like the internet, access is not allowed, because only this virtual network, using this guy as a use case, only this virtual network has been allowed. So which means if there's a VM within that virtual network, the VM will be able to access it. But if I have another virtual network here, that virtual network would not be able to access it. If I had enabled express route peering and I allowed that peering network also, I have VMs on my on-premise that will be able to access it. But once you go off my on-premise network, you get back to the internet, you won't be able to access it. That is endpoint. So simply put, endpoint does what we refer to as access restriction. It restricts who or what can access some of the resources you have here when you create those endpoints. Then you have private link. What private link is doing is bringing that service to be part of your network. There are two different things. This one, you are restricting access. This one, you are making it part of your local network so that it gets an IP address from your local network, and accessing it will be restricted to local connectivity. So let me give an instance. Let's say, if you have a website, if I have a website on my local network, it is accessible to everybody globally. But I can say I only want people from, okay, thank you. Using the issue of Twitter we talked about the last time, let us assume that ban was done by Twitter. All Twitter needs to do is just to pick up the Nigerian address space and restrict it on their network. So everybody within Nigeria will not be able to access it. But let's make it a little bit more granular. Maybe Twitter has got issues with MTN. Then they know the block of IP address MTN uses for public internet and even for their customers. They can either explicitly allow or probably deny, as the case may be. That is what you are doing with private endpoint. You are restricting access to Twitter. But if I say private link, what Twitter is doing is extending their network or probably that service to be part of my own local network, so that I can access it using a local IP address and not a public network. Then also my traffic to access it will not be routed through the public network. It will be a local traffic. That is what a private link is. So private connectivity resources, traffic remains local on the Microsoft network and there's no public internet access. And you have integration with on-premises and cloud network as well. And here you have, in the event of a security incident within your network, only the mapped resources will be accessible. So when you have issues, maybe someone attacks your local network, only that service that you have extended to your local network will be impacted. Unlike if it is endpoint is still done across the internet. So if there's any attack to the internet, it still impacts that particular service. So let's look at how both of them are done. Something was running here before we left. The move. Is it done? If it's done, this guy should change to ECS2. And you see. Go come back to this guy. So to illustrate this, I'll come here and create a storage. let's say I'll create a storage account. My VNet. This guy is in East US. East US. Okay. So storage account. Yeah, I'll put it in East US. I'll call this storage 01. Is already taken. Storage 0001. Yeah, cool. Okay. So I'll put it in this guy. So to be a standard storage. No, I don't want dual redundancy. I want local redundancy. Then I'll say create. I believe we all remember what we discussed about storage, what we talked about blobs, we talked about tables, queues, and file share. Yeah. So why this guy is creating? Now, to create a service endpoint, the creation of service endpoint is done from your network. So I come here to service endpoint, and I say access to my storage account, which I've created here, should be restricted to traffic coming from this my network here, this network, maybe from HQ, any network coming from HQ. I'll come here and I'll say storage. And here I'll specify, okay, maybe both from Abuja, because within this network I have two subnets, Abuja and Lagos. They're both from both of them, or maybe just Abuja. I would say just Abuja. Then I'll come here and say add. Now you would see that in creating the service endpoint, it didn't give me an option to be specific with this storage account that I have here. It is just saying all the storage service, because storage account is a pool of service where everybody goes to create their own. So I go there and create my own. You go there, you create your own. But this restriction is saying that when I'm accessing the service in its entirety, restrict it to this network. So if I'm restricting access to it, to this particular network, yeah, my connectivity to access my own share of it may be localized, maybe what's it called, kind of protected using that IP filtering. But the whole of the whole storage service as a whole is still accessible through the public network. So now I've done this, so I have a service connection point, and it means that if I want to access my own share of, which is this storage, it is restricted to this IP address entirely from within my network. So, but that doesn't give you that depth level of protection, because I'm always saying from within this network, restrict access to storage account. But now I want to be specific to say, for this my own storage account, this storage 00001, I want this storage 0001 to be localized. I want it to be part of my network. I want to see it as a local resource so that I access it using a private IP address. Then I'll come to networking. You can see now I'm not doing it on the network. I'm doing it on the service itself. Then I'll come to private. Even though one of the restrictions you can do directly on the service itself, it's even to say enable it for public access, or probably to a private access, what's it called? A private network with a specific IP. If I come here, this showing, let's see, available. There's a part where it should show me what IP address I'm currently using to access that, but Let me come back here. So if I come to networking here, okay, yeah, it's even here. So internet routing, private IP address. Okay, yeah, that's it here. So this is what I was looking for. So this is my own current IP address. So if I come here, which is the public IP address my service provider is assigned to me. If I come here to say, so you can see this is my IP address. And if I come here, and here it's giving it to me. So what it's telling me is that, guy, if you go and restrict access to this storage account to a virtual network, and you put the virtual network here, and you are currently connected from the internet, once you say save, you'll be disconnected from this guy until you go and connect to it from the virtual network. That's why it's saying to be on the safer side, add your own IP address. So that is what this guy is saying. So that is you restricting, creating some kind of firewall restriction to this guy. But it means that I would still have to, first of all, access this guy through the public. And even when I'm accessing it from my own virtual network, the traffic will still go through the public. But now I want to localize the traffic. I want to localize the access. Then I'll come here to create a private endpoint connection. So I'll say private. This guy, I would say private to HQ. Private to HQ. And so you can see network interface name. This storage is a PaaS service. It's not a compute instance. It's not a computer where you can give an IP, a network, or probably an IP address. But for you to localize a service and make that service part of your local network and have its own private IP address, it needs a NIC. So in creating this, Microsoft would assign the whole mechanics of that, how it's done. Behind the background, you don't know. Maybe they'll create a virtual machine and give it a NIC and give it an IP address, or they'll do. But the bottom line is that this guy would get a network interface, and that network interface will pick a local IP address for my VNet, and I'll be able to access the storage as if it is a VM on my network. So I'll go next. So which part, because of this storage account, can host any of this type of storage? Block table, queue, file, web, or brand DFS. Which of them do I want? I would say maybe file. Then I'll go to networks. Then it will ask me which network and which subnet. So my network here is HQ, and my subnet is Lagos. So network policy for private endpoint, I say, well, what type of IP address do you want? Is it going to be static or private is going to be dynamic? I would say I want it to be dynamic. Then application security, those network security groups, do I want to be able to restrict access to that NIC? You can remember your network security group can be tied either to a NIC or perhaps to a subnet. I don't want. Then come here again. This is making sense here. So if you want to access this storage, once you create it, you see the IP address assigned to it. You can either begin to use the IP address directly, or you tie it to a DNS. So by default, if I go ahead, it's going to create this private DNS record for me. It's still the DNS record being used for private DNS name. If you remember when talking about storage, we talked about their endpoint addresses, where you see something .file.blob, which would be the unique identity used to accessing those particular services. So it's going to create one for me here. So I can now create a CNAME record for this guy so that I can access it at, let's say, maybe file.raji.com or probably file.rajiadwali.com. I'll go next, and I'll just go ahead to say create. So what this private would do for me, in simple terms, is that it would localize that service to my local network. So I would see it like it's a local service, even though it's a public Azure service. Oh, your own safe. No, I didn't say close. So we'll come back to see this guy once it's done. So now let's talk about load balancer. We've discussed load balancing large number of time and give instance to say when you want to increase availability of your service by means of managing performance of the node, you can use a load balancer. So if I have server, I have another server here. Both of them are hosting the same website. I can put them behind a load balancer so that what users will access is the load balancer. Then the load balancer will now direct the traffic to them. So if tomorrow I see that the traffic for these two servers is becoming too much, I will add another server and still tie to the load balancer. To the user, there's an abstraction here because what they see is the IP address of the load balancer and they will assume that is the server and it's just one server. No, it's just like Facebook. Can you imagine a number of servers that are responding to your requests when you do www.facebook.com? You can only imagine. There could be in thousands, there could be in 100,000s, spread in different places, and you are hitting a load balancer or probably some kind of web, what's it called? Like maybe a traffic manager or probably a CDN or probably a web application gateway that begins to distribute the service. So if I go to www.facebook.com and you go to www.facebook.com, the server that may respond to your own request may be different from the server that responds to my request, and that is what a load balancer does. Now, Microsoft has got the load balancing concept available under four. These are 4 different services. You could have a normal load balancer, which operates at layer, that will be layer 3. It can do TCP and UDP. Or you could have an application gateway or a front door that operates at layer 7. And it can begin to manage HTTP, HTTPS, or probably HTTP2 traffic. Or you could have a traffic manager that can do any. You could use it to manage just network traffic or probably application-specific traffic. And their use cases would always differ. And for instance, for web application, you could use it even privately within your local network, likewise a load balancer. But for front end and traffic, you could only use it to manage public traffic. So you can't use it to manage private. So these guys are global only. And your environment, what could be your back end pool? That means what could be the resources that you are sending traffic to. It could be resources on Azure. It could be resources on other cloud, like maybe AWS. It could also be resources on your on-prem. Likewise, your front door. But if you are doing local load balancer, it has to be, you're only load balancing using VMs directly on Azure. While for traffic manager, it could also be on Azure. It could be on another cloud provider. It could also be on-premise. Then what are the security integrated with some of this? You could have web application firewall attached to your application gateway. For front door, it could be WAF and network security. While for load balancer, it is network security. While for this guy, you don't have to manage any security rules to them. So the way you implement a public load balancer is also the same way you implement a internal load balancer. The only difference is that for a public load balancer, you are managing traffic coming from the public, which is from the internet. And those traffic are being sent directly to VMs or private resources within your network. So a large number of times, you are using it to manage web traffic. Why for internal load balancer? Your internal load balancer, it could be that you are using it to manage access to another resource, not necessarily web. For instance, traffic coming from VMs, you want to use it to load balance it to SQL, so that I have several SQL servers, and it doesn't really matter which of the SQL server any of these VMs connect to. So they are local. And you have 2 tiers or SKUs of load balancing, depending on you have basic, you have standard. More or less like if you have some of these pricing tiers where the more you pay is the more you get. If you are going for the basic, you could have up to 300 VMs behind the load balancer, while for standard, you could have up to 1,000 VMs. For when it comes to health probes is how does the load balancer know that a particular VM that is connected to it is still alive and can still accept requests. So it sends health probes or probably signal, maybe every 15 seconds or probably every 5 seconds. If that server does not respond to maybe 2 or 3 consecutive probes, the load balancer assumes that it is dead. So when there's a new request, it doesn't send it to that particular server. So that's what, so let's look at what creating a load balancer looks like. So is this guy done? So if I come here and refresh, no, stay on page. Yeah, private endpoint is done now. So I'll say okay. Where's that? If I come, this is okay. Yeah. So this is my storage, and my storage currently has a private endpoint. Here I can see that this guy is approved, successful, and it has a nick. If I click on this nick, I'll see what IP address is tied to it. So the IP address that is tied to my storage account is 10.0.0.4. So which means that I can access that storage account using that 10.0.0.4 IP address. So if I come here, and look at private endpoint, so you can see from my network, I can see that I have a private endpoint, which is that private endpoint that is used to access my storage. So that is the way private endpoint works. Now, let's look at setting up load balancers. If I come here, okay, I have one VM here. So I'll create another VM quickly. So the scenario will be that I have 2 web servers. I have 2 web servers. Okay, let me use this space for an e-commerce site that I'm just setting up. And I've been told that we want high availability, and I want the whole e-commerce site to be able to be resilient to the amount of traffic. So even if traffic increases, you don't want it to impact user experience. So I just thought, okay, now I could have several VMs, one VM, another VM. Then I place a load balancer in front of them. So I'll go ahead now. I already have one VM. I'll create another one. I'll call this web O2. I'll call this web O2 East US. Yep. This guy. Select this guy. Why thou not selecting? What's going on? Go next. I want this guy to standard. So I don't want, because these guys, I won't be accessing these guys in silos directly. I wouldn't want them to have a public IP address. So for public IP address, I would say I don't want any. Instead, because users will not be accessing these web servers directly. And this guy is in, let me put it in HQ. And in which VNet do I have the first VM? Virtual machines. One. So this guy is in Abuja. So there's this guy also in Abuja. Yeah, that's fine. I don't want it to have a public IP address. Network security basic. Go next. Then I'll just say create. The current one that I have has a public IP address. When we created it earlier, I would remove that public IP address and take it off. So I would come here, I would associate this guy. So both of them are just local to my network. So which means they're not accessible from the public internet, because I want to place them behind a load balancer. So I want these guys to be web servers. On Linux, just like you have IIS on, Windows, the web server you have on Linux is Apache. So I would install Apache on these guys. You can either do that by connecting to the machine directly through the shell, or Azure allows you to even run script on the virtual machines without actually connecting it. So I can put my script here. So this guy would update the package manager on Ubuntu, that's apt-get. It will install Apache. It will also update. You have local firewall, just like Windows Advanced Firewall that you have on the system. You also have the Ubuntu firewall on the Linux machine. So the version, I want to open up Apache, which is going to port 80 on it. Then also, this is my VM01, so that I'm able to differentiate. Although when you are using web servers behind the firewall, it means that the web application is the same on both servers, so that users don't even know which of the server they are connecting to. But for me, I want to be able to know which server I'm connecting to. So I'll do one or two things to just signify that, oh, I'm currently connected to VM1, or probably I'm connected to VM2. So when you install Apache, there's a default website, just the same way you have a default website for the member. There's a default website on IIS that shows that IIS blue screen. That's default website. There's always an index.html file there. So I'll just modify the index.html file here and put the name of the server on it, so that when I load that page, I see that, oh, this request was handled by VM1. If I refresh it, if the server changes, it also shows me that the request is handled by another server. So I'll do this. I will run this guy. Where's my VM? Is it done? Yeah, this guy is done. So I'll do the same thing here. I don't even have another means of running that command, because I've said this guy should not have a public IP address. So which means I can't connect to it through the shell, because for me to connect it through the shell, it must have a public IP address. So either I run the command this way, or I use a bastion host. If you remember bastion host. So a bastion host is going to set up a VM for you, and that VM would restrictly is an add-in and secure VM through which you can now begin to connect to resources on Azure that are local to your VNet. More or less like a security approach, improving security of access to your services. So I'll run this guy too. So while these guys are running, because I just need them, I'll come and now create my load balancer. Now, I said that the load balancing service is provided on Azure, can be provided using any of these.
Web Application Gateway offers you load balancing and also advanced security to your web application. So it includes a web application firewall and it operates at layer 7. So that means I can begin to manage traffic that comes, web traffic to this server. I can begin to do routing part. So that means if I go, what do I mean by routing part? Let me do notepad. What I mean by routing part is if I say www.raji.com/ let's say web, I can do this, and www.raji.com let's say download. I can do this such that I specify different sets of servers. When you access the download page, only different set of servers would respond. And when you access the web page, only different set of servers will respond. That is possible with Web Application Gateway. It is also possible with Traffic, what's it called, Manager. CDN front doors is also possible, but primarily what I use front doors and CDN for is to manage static web content. They actually called content distribution network. And you can do both for front end and traffic manager. You could even do regional routing. So that means I would have different web servers, and that is the way some of these global web services work, like let's say Facebook or probably a Google and stuff like that. You have a set of web servers, let's say VM1, 2, and 3 for say the Africa region. Then you have let's say VM4, 6, 7, 8 for the Europe region, and maybe 81 and stuff like that, let's say for the US region. So due to the fact that your IP address is always tied to a region, if I go to www. Let's say facebook.com, if I'm using a traffic manager, the traffic manager will do a lot of all those resolution, identify from which geographical location am I connecting to. Then it routes my traffic to this set of servers. If tomorrow I travel to Europe, or maybe I use a VPN, then it's going to determine what is the region of my public IP address. It says that is Europe, then it routes to this set of VMs. There are some of those advanced features that you have with Traffic Manager and even front door. But here we'll be looking at we could look at web application and also look at load balancing. So first, I'll come here to create a load balancer. I'll say create. This guy done. Okay, this script is done running. This one also done. This guy, okay, it's also done running. So I'll come here. 7 ACS. So I'll call this load balancer 01. So I'm going to go for the standard one, and it's going to be public because I'm using it. I want it to route public traffic. So it's required that I have a public IP address. So the first thing for my front end pool configuration, I'll call this front end pool. It's going to be IP version 4. I don't have a public IP address yet. Okay, I had one. Okay, yeah, this one was the one I dissociated from my. But let me just create them down so that. So I'll call this load balancer IP 01. Say okay. Just say add. That's my front end, which is my public IP address for public facing part. My back end would be what are those servers. So if a user connects to this public IP address, what are those servers that would handle those requests? So I'll come here to create my back end. I'll call this backend 01. My servers are in HQ. I want to identify them by virtue of their NIC or maybe the IP address. I could say Nick. So I have the first one here, I have the second one here. Both of them have got different IP addresses. I'll have them here. If I have 100 of them, since I'm using a standard SKU, I can have up to 1,000 of these servers on my back end. Then I would say save this guy. Then I will now have to come and create a rule. When the traffic hits the public front end, how does the load balancer determine how to send it to the back end? So I'll come here to say I want a load balancing rule. I'll call this rule 01. So front end IP address is to be created, which once I click on save, it's going to create it. And my back end pool is this guy. So I'm saying that when there's a traffic hitting my front end, send it to the back end as long as the request is coming from port 80, send it to the same port 80 on the back end. And for help probe, okay, how do I know if any of those servers are still up? That is my backend pool servers, if they are still LD or not. I'll say send ICMP probes. It could be anything. Just send help probes. ICMP could be ping it or stuff like that using TCP, HTTP, or I can say, okay, now always try to connect to port 80. Try it at an interval of, let's say, every 5 seconds. If the server does not respond after trying it maybe 3 consecutive times, consider that that particular server is down. Then take it off the backend pool. So that, because if it does not take it off the backend pool, the load balancer would assume that the server is still up, and when it responds with that particular server, users will get an error message saying that particular service is not available, something like that. Then session persistence is would always be used if you want, for instance, if the first time I go to facebook.com and the server that responds to me is server 01, as long as my session is still open, because each time you refresh your browser or you click on a link, that is all unique requests. I go to a website now, that is one request. I click on a link, another request. I click on anything, they are all individual requests. So it is saying that once I do my first connection, all subsequent requests should it still be load balanced across different servers so that the server that is available is the one that responds, or I want that same guy that responded the first time should be the one to continue to respond to me as long as that session is still active. That is what session persistence is talking about. So I can either say yes, allow sessions persistence for the IP and for client IP. So if a particular client connects to the load balancer using a specific IP address, as long as the client continues to use that specific IP address, server 1 should always respond to it. Or I can say client and protocol. As long as the client is still connecting with the same IP address and it is connecting to the same port number, let server 1 continue. Once the IP address or the port number changes, then any other server can respond. So, but here I don't want persistence. I'll say I don't want. I'll just say add.
So I have this. NAT is if you want servers on the back end pool to be able to connect to the internet, then you have, because now they don't have, I've taken off the public IP address for one of them. For the second one, I didn't create the public IP address. So which means currently they may not be able to connect to what's it called, the internet. So if I want them to connect to the internet through the load balancer also, I can do this. So an inbound now through forward incoming traffic sent to selected IP address and port combination number to a specific IP address. So I'll go to say outbound rule. I don't want any of these. Then I'll go create. Okay, this guy is, so these two guys. So why that guy is creating. Now, if you remember when we're looking at the slide, one of those things that you have as security for load balancer is network security group. So which means, despite the fact that I've created a load balancer, a load balancing rule here to say connect to port 80, if I come to my VMs, if you remember, we still have network security groups. If I come to connectivity, this is my VM. Let me close this. If I come to networking, I have my network security group where the this guiding creates, okay. Let me come to interface this, the network security group. Okay, thank God. This guy does not have any network security group, so no problem. If it has, then I'll have to create a rule to allow port 18. So let me check for this guy as well. Networking. This guy has. So for this guy, I either take it off or I come here, because presently through this network interface, connection through port 80 is not allowed. So if you remember, then I'll have to come here to create an inbound security rule. From any to destination, any custom HTTP, that is port 80. I'll just say add. So this guy is up now. So now I have my load balancer. The public IP address of my load balancer is front-end IP configuration. This is the public IP address. Now, this is what users would use, or if users are accessing, if it's a private network, I can use this to create a record within my private zone or maybe a public zone or thereabouts. But if users need to access that website now, this is what I would use and map an IP address to. So if I go to this, so you can see this guy. So currently, the machine that is serving my request is VM 02. So I'll send this IP address to us. You could try it from your end and tell me which VM is responding. Try to access that IP address from your browser and check which of the virtual machine is picking your request. Are we trying it? Hello?
Yeah, Raj.
Yeah, let's
Hello?
try it. I want to know what VM is responding to your request. You could just pick up the IP address, just put it in your browser.
I don't know if any other person is trying it. I'm having issues here.
Okay. So it's possible that if someone tries it, it gives another machine response, and you have it that way. So if tomorrow I feel like this, the amount of traffic that I'm having is becoming too much, such that those two machines cannot manage that request again, all I need to do is go and add another server to the back end. That means I increase the number of servers to, let's say, maybe 3 or 4. But considering the fact that I'm using the standard SKU, I can increase it to up to 1,000 servers. So that's the way the load balancer works. And it's also similar to the way you set up your web application firewall. Sorry, your application gateway rather, which makes it your web application firewall. So if I come back to load balancers, So this time around, let's using the same set of servers, would create a web application firewall. I keep saying web application firewall, web application gateway, primarily because one of the advanced features of the web application gateway is the fact that you have a web application firewall, which helps you protect your web application from any of the attacks. Some of us will be familiar with the OWASP top 10, OWASP top 10, which are the top 10 type of attacks or maybe security vulnerabilities that a web application can have. The WAF that is integrated with this application gateway has security control, private firewall rules that protect your web application from those top 10 vulnerabilities. So I'll call this web gateway 01. I'll make this standard also. East US. I want East US to where's East US? Yep. So this guy can automatically increase based on how much, because you can use it for more than one type of application. That's for this guy. I could have different websites and I use the same web application firewall for them. So the number of traffic that will be hitting is will be much. But I want the web application firewall also to be able to scale as the number of workload increases. So I can say scale between 0 and 10, depending on traffic. I'll put this guy also on my cloud network 1. So this guy would require a subnet specifically for the web application. If you remember, when we're talking about firewall, we said the firewall would require a dedicated subnet. That's the same thing as your web application firewall. It requires a dedicated subnet. So I can't put it on the Lagos subnet. I can't put it on the Abuja subnet because I have non-web application services on those subnets. Whatever subnet I would have to put, it has to be a subnet dedicated for web application. Although it has no restriction on what should be the name of the subnet, unlike for the firewall, that has a restriction of what exactly should be the name of the subnet. So I could call this guy, let's say WAF 01, and I'll just use this subnet. So then I would come here back to this guy and I'll say use where is it? Come back here and just say create. I'll call this guy WAF 01. Yep, and this guy should be in East US. We have my existing. So tier, okay, I would use this guy with web application firewall. I would let me create a WAF policy. I'll call this WAF 01. I want it to also add bot protection to it. I'll come here to say I want it on this VNet, on this subnet. So I'll go in yes. So for this also I have to configure my front end, which would be a public IP address. Yeah, let me just use this. Then I'll go next. Back end, I would have to create my back end pool, which will contain my virtual machines. First virtual machine is this. Second virtual machine is this. Yep. So I'll click on add. Then I'll go next. Configuration for here. I have my public pool. So here I have to create my routing rules. So remember I said This guy has flexibility for you to be able to use it for more than one application, and even for you to be able to use it to route traffic for specific paths. So you do that by first of all creating a listener, which, because it's this guy operates at layer 7, it's able to pick specific parameters that has to do with your web protocol. So I'll call this guy okay, I'll call it rule 01. I'll call this listener 01. My protocol is 80. It's going to be basic or multi-site. If I want to use it for more than one site, I have to put that here. Error page, I don't need that. Then here I have to specify my target. Backend pool is this guy. Backend settings. My backend settings, I'll say back set 01. What do I want here? It's going to be port 80. Number of if I want to enable all this cooking, connection draining will mean that if there's a backend server that is down, don't just cut the existing session, gradually move the session to an LD machine. And your request timer is number of seconds that the application will wait for a response for the backend before you consider that backend as inactive. So here, do I want to use a specific host name header? I don't need that. So what my backend pool is this guy. So it says something is wrong with my listener. Okay, the public IP address for my listener. So I'll go ahead to say add. Next, and I'll just go ahead and say create. So this also would provide me with a public IP address. So which means I have a load balancer that is using the same set of server as backend, and also a web application gateway that is still using the same set of servers as backend. Both of them would pretty much do the same thing, but with the application gateway doing more in terms of security checks, in terms of how many web application I can do it, in terms of the depth of what I can configure with the rules, because I can go very granular specifying header information, or probably even network, what's it called, URL path, like www/ all those // I can use web application to actually manage that. So it's done with one of the components. This guy. While this guy is going through, we talked about persistence. So this is web application firewall. You can see you could have more than one website, especially when you are doing multi-site. www.consultor.com goes to this set of VMs. www.fabricam.com goes to this set of VMs. I could also specify paths to say from within the same website, but if I have different paths, should be different servers handling them. And this just defines the approach or component required to create a SSL application. Create your front end IPs, your listeners, your route backends, your firewall rules. If you have web application firewall enabled, you have to create your policies and rules, and also probing. This guy also supports SSL offloading, so which means you could use it for HTTPS specific sites. And for the offloading, your response to HTTP requests can always be done by the firewall as against being done by the web server. That is what offloading is all about. Let's see if this guy is up. Okay, it's still running. So why this guy is still running, we'll come back to it. The last part of this lesson is Network Watcher. So Network Watcher basically is a set of services that you can use to troubleshoot when you have connectivity issues. Considering the fact that your VNet is not that physical network where you can go and check cable, you can begin to check for routing parts. Is there a port that is bad and all those stuff? But the fact that it is not physical doesn't mean that there still can be network issues. But when some of those network issues arise, how do you begin to monitor your network or probably even troubleshoot and pick them up? So it's a regional service and it's specific. You can only deploy it for the same region where you have your network. You have different services like the IP flow that helps you diagnose network connectivity. You have your NetHub that would help you determine if your traffic is being properly routed. You would also have VPN diagnostic. It could do a visual representation of what your network layout is. You could also troubleshoot connectivity issues to your VM. Why can't I connect to my VM? Is it due to a network security group, or probably is it because the VM is down or stuff like that? Why this WAF is creating, we'll come back to it once it's done. I'll come here to Network Watcher. So my Network Watcher, I have here, I have a number of them already running, and these are the diagnostic tools I have. IP flow verify. It helps you check if a packet is allowed or denied from a VM. Here, what I can do is, for instance, I can say from this particular VM to have another VMs, like I have another VM at .5. I want to check connectivity between them from port maybe port 80 to port 80. Check connectivity TCP, and I would say check. This one says no network security applied on a NIC. So no network security applied on a NIC to allow or probably block traffic. So one of them does not have NIC. So this guy cannot check because traffic restriction is only done using a network security group, which I don't have. I can come here again to say, or better say, let's look at another scenario, maybe from web 1. Network interface, this guy. I can check from this guy to say maybe Facebook. If I know the IP address of Facebook, just to check if that guy can reach Facebook, www.facebook.com. Ping. For instance, I want to determine if that guy can reach Facebook without logging into it to do a ping. Facebook port 443. Although this guy can be a random port, but let me still say port 80. Yeah, port 18. So this would help us check and give us response. If I need to capture network, for instance, if I begin to, so this guy says access is allowed and the traffic is routed because there's a network security rule that allows port 80 outbound, but moreover, the remote I'm actually connecting to is 443. So naturally, this does not really matter because it's source. So this is doing more like a ping from this guy to this guy to port 8443 and tell me if it's up or probably responding. The same thing, you can do this to diagnose if you have inconsistencies in your network security group. For this guy, if you want to determine what will be the next up IP address, so if I am connecting to Facebook, who is helping this guy to route the traffic out, which is NetHub is more or less like saying, what is the default gateway for this guy? If this guy wants to send network traffic out, because the destination I'm providing is an external destination. So which means the next up for this guy would be, says internet IP address. So although it's not giving me what internet IP address is, and it is using a system route. So the fact that I can't view that system route, it just knows that this guy is able to connect to this guy using an internet IP address, which is defined in the system route, which is also fine. If I have VPN, I can troubleshoot. Here, I can also capture packets. That's if there's a need for you to use stuff like Wireshark to capture a packet and begin to diagnose the content of that particular packet. I can add the request here and specify a storage. The network capture will be done and stored in that particular file storage, from where I can download and begin to use any packet analysis tool to monitor. Then I can also create a connection monitor where I want a particular constant monitoring of a particular service, such that if I come there, I just see what is the status of that particular service. I can do that here. I can call this, let's say, Mon3 is US. I go next. Then I'll specify what do I want to monitor. For instance, I want to monitor traffic from, let's say, this virtual machine. I want to monitor traffic from this virtual machine, this web01 to where? Let's see, under VM. Okay, maybe from VM1 to VM2, because I don't have much of resources here. I'll go here and say add. And how do I want to monitor it? I could say I want to monitor by initiating a TCP connection or ATP connection, or even pinging. Ping is IP, ICMP. I would say by pinging this guy, and I would say add this guy. So I'll give this guy a name, Mon003. So each time I go, I can just go there and see, it's still creating it. I can just go there and see what the status of this connection request is, and it's going to charge me 0.3 cents per month. So I'll go ahead to say create. So coming back to see our web application firewall, I saw that guy was successful a few seconds ago. So I'll come back here home. I'll come to load balancers. Then I'll come to web application gateway. So this is my web application gateway here. Here also I have my public IP address, which is this guy. So if I come here and put that here as well, let's see which machine responds to my request. So the request for this is responded to by VM01. So you can see the same way. This one is the IP address of the load balancer, which is still responding to requests. Oh, sorry. IP address of load balancer, which is still responding to requests, and this one is the IP address of the web application gateway, which is also responding to requests, except that for my web application gateway, I can do a lot more SSL settings, web application firewall, where I can begin to add rule sets that helps me monitor and prevent any of the attacks defined in the OWASP top 10. I can begin to create rules to help me manage those. That's why it's called a web application firewall. So that is where we would draw the curtain for today. So the last one is visualizing your network topology. We've done a lot of configurations around our network. We even want to have a visual, what's it called, look of what our network layout is, more or less like you having Azure to help you create a network diagram. So I can come, okay, let me do that under my network watcher. Come on. It's not here. Okay, I'll do that under my network. Okay, I have it here. Though I could view it also under my VNet as well. Put this guy here, my HQ cloud, and say I want this. So this is saying you have sorry. Can view it from here, from here, diagram. So from within the network itself, you can view it as diagram, or from within your network watcher, you can view it as a topology. So I have a network here. On this network, I have 3 subnets, Abuja, Lagos, and WAF. On this subnet, I have one machine connected to it. I have the one machine with the HQ NIC, another one with Web 139. Okay, I have two in Abuja, rather. Two in Abuja, one in Lagos. So I have two machines connected to the subnet in Abuja, one in Lagos, and I have a web application firewall subnet. So this machine here is currently part of a pool for a load balancer, and that load balancer, you have the health probe done using ICMP, and it has a front-end IP address. While this guy also is also part of the same front-end and back-end pool. They both use ICMP for load balancing. Then for web application, it's not giving details of the web application, but we know that there's a web application gateway here. So you could just download this in JPEG or whatever and use it as part of your network diagram. So that is that so far. Any question? Questions? Hello? Hello, are we there?
Hello.
Yeah, any
Yeah,
questions?
Wale, I can hear you. None from me.
Okay. So we have two set of activities to complete. We're working with DNS and network peering from the last two lessons we had last class. And here you would create a load balancer, implement an application gateway. You'd also configure routing for a hub and a spoke topology. I'll share the list of those activities in the Discord channel and additional details for us if we need to check up some of these stuffs to aid our understanding. So see you guys next week.
All right. Thank you very much for your time.
Yeah, you're welcome.